Good morning, everybody. How's everyone doing? Welcome back to our daily pre-cal videos. Today we're going to continue talking on about sine and cosine functions, and we're going to look at vertical shifts. So for a vertical shift, it's just exactly what it sounds like. Now for this, they're going to talk about a little about its max and min values, but it's just the average of them. So the vertical shift of a sine and cosine function is the average of the maximum minimum values. Okay, so you got to remember back the maximum minimum values for a sine and cosine function, just their parent functions, are 1 and -1. So when I average those out, I get a height of 1. So that's typically what it's saying, but we're going to look and see what a vertical shift and how we can actually define where that location actually is. So we're going to look at this side over here. Okay, we have our typical functions again. Y is equal to a sine x bx plus c plus d, and y is equal to a times cosine bx plus c plus d. Now the vertical shift for this one isn't an equation. It's a simple letter. This is d right here is always going to be your vertical shift. So to kind of look and see what that looks like, okay, we have these functions over here. We have our parent function for cosine x in blue, which is this line right here. It has 1 and -1 max and mins, and it goes down and does our thing. Okay. Then we have a altered version of g of x. So g of x is equal to cosine x plus 1. So it has a vertical shift of 1, and you can see all values simply go up 1 unit. Okay. And that's all a vertical shift really is. So let's look at our problem for it. So once again, we're always going to use, more than likely for these problems, we're going to use everything we've learned and put it together. So the first one says, or the first one we're going to look at is to state the amplitude, the period, frequency, phase shift, and vertical shift for f of x is equal to sine of x plus pi minus 1. So we want to find a few things. So the first thing we're going to find is the amplitude. And we know the amplitude should be coming from A. Since there's nothing in front of sine, okay, that tells us the amplitude is equal to 1. Okay, if there's nothing there, it has to be equal to 1. The second thing we're going to look at is the period. So period. Okay. For the period, we say that's equal to 2 pi over the absolute value of b. Since once again there's nothing in front of x, b is said to be 1. So 2 pi over 1, or just 2 pi. So we have a period of 2 pi. Then we want to do the frequency. And we know frequency is equal to 1 over the period, or the absolute value of b over 2 pi. Since we have the period, we're just going to use that. So we can say that frequency is then equal to 1 over 2 pi. Okay. Look at the phase shift. The phase shift is equal to negative c over the absolute value of b. So we're going to take that from these. We're going to take our c and our b values, and we're going to plug them in. So c for us is equal to pi, and our b value is, once again, absolute value is just 1. Okay, so we end up getting a phase shift of negative pi. So we'll say phase shift is equal to negative pi. Okay, and the last one we'll look at is the vertical shift. Vertical shift, and we know that is going to be found by, so we're going to say Vs is equal to the letter D in this instance, and that's just equal to negative 1. So in this instance, we have all our values, so we know the answers. Okay, we know the amplitude, the period, the frequency, the phase shift, and the vertical shift for this function, and that's about it. Okay, so Like I said, we're going to keep adding on top of these. They really don't get more difficult than they are. We just add a little more to them. Okay, so just make sure we're doing this. And guys, if you're struggling on these, go back to the previous videos and watch them, because as you can see, we're just going to add on answer choices to these type of functions. Okay. Other than that, that's it for today's video. Okay. I hope everyone's having a great day. Okay. Peace.